Welcome back to the Energy Networks Innovation Conference. It's great to see so many of you tuning in this morning to hear our second set of keynote speeches. I hope you have some refreshments at hand because it's going to be another information-packed day. Today we're going for a real treat. We're going to learn about some of the innovation projects happening right now across Europe, our nearest neighbours, and of course, let's not forget that we are connected to Europe by a series of subsea cables and pipes. And these cables and pipes are going to be required for a long time to help us balance our energy system. So we're going to kick off by hearing from Christian Ruby of Eurelectric. And his talks about one of the major themes of today's session, shaping an energy inclusive transition for consumers. We'll then hear from Ørsted's Duncan Clark on his approach to innovation as one of Europe's leading and most agile renewable energy producers. And we'll finish our keynote speeches with a panel session which will look at international net zero and in order to accelerate our pathway in the UK. For the benefit of anyone who didn't attend yesterday's sessions, our delegates are welcome to ask questions using the chat text facility to the right of your screen. Now it's my great pleasure to hand you over to our first speaker, Christian Ruby, the General Secretary of Eurelectric.
Hi everybody, my name is Christian Ruby. I am the Secretary General of Eurelectric. Eurelectric is the trade body of the European electricity industry. We represent the industry towards policymakers in Brussels. We have companies across the value chain involved, 3,500 of them, and the aggregate turnover of the sector is some 600 billion euros per year. I'm going to talk about the just transition, how to shape a just energy transition. What is a just transition? Why is it that the electricity industry should care about this? And what can be done to ensure a just transition? This is what I'm going to give you a few insights in. It's a topic that we hold very dear to our hearts in Eurelectric, the European trade body for the electricity industry. And we've been spending quite a amount of resources to look into this question in some depth. So shaping an inclusive, just energy transition is basically for us about ensuring that nobody gets left behind in what we see as the biggest industrial transformation of the 21st century, which is the energy transition, the transition to a net zero economy by mid-century. We think shaping a just transition is important because essentially we see this is the only way to ensure the transition. We acknowledge fully that there's a climate problem and that we have to solve it. We have an essential part to play in solving it. And we know that only by getting everybody on board are we going to succeed with this. Why is that? Well, essentially because this transformation affects every aspect of the economy. And it's pretty simple math that if anybody or even a big part of society doesn't see itself as benefiting from this transition, then we're not going to succeed with this. We have to acknowledge that that this transition is happening on the backdrop of a pretty serious economic situation. Since the 1980s, the inequality in European societies has been on the rise. When we look back 40 years ago, the divide between the richest and the poorest would be some factor 7. Today, we're closer to a factor 10. And on top of that, we have a corona crisis, which has really exacerbated both the inequality and the seriousness of the economic situation. When looking out in Europe, we're talking about a contraction in 2020 of some 7% of GDP. I understand that in UK it's even worse. And that, of course, has ripple effects for unemployment, which is significantly on the rise, both in Europe and the UK. And that, again, adds to the inequalities. Also because the unemployment is really different amongst different segments of the population. If you look towards the general population, we're seeing in the UK unemployment rates of around 5%. If we look to the young people from 16 to 24 years old, we're closer to 15%. And mind you, these are the people that are going to go through the full stages of the energy transition over the next 30 years. So if they don't see an interest in this project, we're not going to succeed. That's why in Eurelectric, we think that a just transition that leaves nobody behind is absolutely essential in order to succeed. We've seen what it looks like if we don't have everybody on board for this transition. The people that have been involved in European politics know the deep strides we've had and the fights that there have been with some countries that have a very different hill to climb on the energy transition. And we see also in individual member states how the economic effects of climate policies can trigger civil unrest. You probably all remember the yellow vests. It feels like a life ago already, but actually this movement found its way well into 2020 before the lockdowns came. And we've also seen violent riots, for instance, in Spain, when Nissan decided to close down its combustion engine car factory. And even in well-off Norway, we've had the so-called road toll crisis. They put in place a policy to give an exemption for electric cars from the road tolls, which meant that the rich CEO in his Tesla could drive for free, whereas the single mom with a secondhand diesel had to pay. And that, of course, was perceived as very unfair. So we have to get the social dimension of climate policy right in order for everybody to accept it and have the sufficient buy-in in this energy transition. And that's basically the background for our endeavor to understand what are the social impacts of climate policies and what can be done to cushion or even offset them if we see those adverse social impacts of climate policies. We worked with a number of our experts and a very able team of consultants from the UK, from Guidehouse and Cambridge Econometrics, along with the NL Foundation from Italy. Essentially what we did was to try to understand the social impacts of climate policy along three different dimensions. First, the national dimension. How does this look for a country that has a completely different starting point for the transition? How does this look for regions that basically have industrial clusters that are related to fossil intensive production? That could be a car manufacturing plant or a fossil fuel plant of some kind. And last but not least, of course, there's the dimension of the individual household. How do climate policies affect them through taxes, additional levies on certain products, and so on and so forth. The first finding we had was that indeed climate policy does have potential social effects and different effects across different social groups. And the reason for this is quite simple, and that is because this transition will affect every aspect of the economy, as I said before. The second key finding, and that's the good news, is that actually these effects can be offset with a variety of different policy tools. We looked into different ways of dealing with this. How have countries across the world gone about basically handling these social effects of climate policies? And we see a lot of very interesting examples across different countries. In some countries, they have gone with lump sum refunds or transfers to certain population groups that were affected by a certain climate policy. In other places, they have looked at taxes, VAT adjustments. Other places, they have gone with energy refurbishment and insulation programs for low-income households. And essentially, you see across member states and across different countries a variety of tools that can be applied. It's important to say that there's no one-size-fits-all. What you do in a country really depends on the existing structure for taxes, VAT, existing programs of different kinds. So you really have to tailor the policy package in each individual country in order to make sure that it works in that context. But the fundamental conclusion stands that you have the possibility of basically handling those social effects of climate policies with a targeted political effort. But perhaps the most important thing, and especially in this time of crisis, economic crisis, is to make the right investments. We know that with entire sectors of the economy really suffering very, very significantly from the economic contraction and the restrictions put in place due to Corona, we have to make sure that we avoid further unemployment. Now, how do we do that? Some people have argued, let's drop all those climate policies as long as we have the crisis. In Electric, we believe that we need to invest in the future and we need to bounce back better. And therefore, investing targeted in the things we know are needed for the transition is, in our view, the best way to counter the economic crisis and to counter the climate crisis at the same time. And this is where the grids come in, because when you look at the needed investments for the energy transition, grids stand out as a key area. We know that the grids need to change in order to be fit for a zero carbon future. That goes for the gas grid, that needs to tackle different volumes, needs to tackle different types of gases, and need to probably connect it to another type of industries and homes and have different connections, at least as compared to what they have today. It also goes for the electricity grids that needs to cater for millions of electric cars in the future, need to cater for more electricity and heating, need to connect to other industries and basically power some of the hydrogen production that we will be using in the future. Last but not least, it also needs to cater for much more variable renewable energy, which will be the bulk of energy production in the future. So we know that without investments in the grids, we're not going to succeed with the green transition. So on the other hand, we also know that this will be capital intensive investments, and it will be investments that will trigger a lot of employment. In Electric, we're finalizing a study on the needed grid investments for the coming decade. And on EU level, we're showing that some 400 billion euros need to be invested. That, on the other side, is going to trigger the creation of some 500,000 quality jobs in the sector, because we need essentially to build as we've never built before. So to conclude, 3 messages. First of all, climate policies can have adverse social effects and trigger imbalances in society. Second, we have a number of policies that can help us avert those effects, cushion them, or even offset them. 3, we have a unique opportunity by investing in our energy grids, in our energy networks, to create a net zero society and help us exit from the economic crisis caused by the corona pandemic. Thank you very much for your attention, and have a good conference.
So hello, I'm delighted to be speaking to you today. My name is Duncan Clark. I head up Orsted in the UK, and I'd like to talk a bit about innovation in energy, and in particular, draw out some lessons learned from the last decade of work in offshore wind. It's been a remarkable decade, and I think we can draw out some conclusions about what's necessary for the enabling framework of regulation and government. We can draw out some real lessons about the benefits of learning by doing. And overarching it all, I think the conclusion is that innovation is so much more than a particular piece of technology, an invention, but is actually a massive collaborative effort across networks. So where we start is probably at the beginning of the last decade, when offshore wind was an interesting and promising, but rather small niche in the picture of energy. And offshore wind turbines at that stage had moved forward from just being a version of an onshore turbine, and we had already developed specific offshore turbines. They were large, but nevertheless, many offshore wind sites were close to shore, sometimes really close to shore, and relatively small, maybe up to 30 turbines typically. And the cost of energy from these plants were high enough that it really put focus on the energy trilemma of cost, security, and environment. And at that time, within offshore wind, it really felt like there was a moment, a testing moment, where the industry could end up being this historical niche, or had an opportunity to step forward, transform itself, and become something much, much bigger. To access that full potential, needed us to get the cost of energy down. And I think today's story is about how that can be helped to happen. And that's a story of innovation. And I remember back then sitting in an industry forum, discussing this challenge and discussing that it would be helpful to set an ambitious, difficult challenge for the sector to address. And around the table, we agreed that the target should be £100 per megawatt hour for offshore wind power produced by 2020. That was the target we set itself. Across the industry, that was considered to be an incredibly ambitious target. And looking back at history now, just to fill in the picture, in the 2019 CFD auction in the UK, the price for electricity was £39 a megawatt hour. So way, way, way better than a target that just a few years before we saw as incredibly challenging. So how has that been achieved? Well, at the heart of it is clearly a step forward in product development. The core wind turbine that has grown and grown and grown, and we're now moved on to turbines of 10 up to 15 megawatt turbines in the pipeline now, with much, much larger rotors, and each of those units being larger helps us get the cost of energy down for a wind farm. And on top of that, we're putting in many more of them. So each project, each wind farm facility is much larger. That also means we've gone further offshore. And that's also helped us access even better wind conditions. So there's a number of factors leading on from that core product that have helped us on this journey. I would say that it's not a trivial thing to introduce a new platform for a new scale of turbine. The suppliers invest an enormous amount of money, hundreds of millions of pounds, to bring a new product like that forward. And one of the characteristics of offshore wind is that it's a highly capital intensive energy production technology. So you make your investment up front, and through the life of the plant, the marginal variable operating costs are quite low. So that means there is a significant quantity of the capital at risk right from day one. So that step of taking a new, relatively unproven new core product like a wind turbine and invest large amounts of money in it at scale, billions of pounds per offshore wind farm, is an innovation that really needs people to come together across supply chains. It really needs a history of experience and of learning and an enormous amount of mutual trust. Typically, it's involved new manufacturing facilities, new product design and proving, and it will typically require hypercare in the early years of the first deployment. So that does require trust across boundaries of supplier and customer and across time. On top of that, that move to much larger sites, much further from shore, also has demanded a similar step forward in the transmission and connection technology that we use. And we've seen major innovation in pushing high voltage AC systems and high voltage DC systems for transmission past what was available 10 years ago into a new world where we can transmit much higher powers, much further distances, and do so much more cost effectively. Some of that innovation has not major invention. For example, on Hornsea 1, the first gigawatt plus scale offshore wind farm to be operating anywhere in the world, built off the coast of Yorkshire in the UK. That's connected into the national grid through the longest and highest power high voltage AC transmission system anywhere in the world. 3 major connections back to shore, all interlinked offshore, and with a reactive compensation station halfway back, which enables a system with such long cables to continue to function. Now, that kind of reactive compensation is not a totally new idea. It's something that has been done onshore, but it is quite a big step to take that and put that on an offshore platform and build that then into such a large and integrated system. It's complex, it's expensive to build, and when you actually first come to operate it, you also need to develop new processes and protocols. So again, I think the lesson to take away from that is how many different parties are involved and over quite an extended time period. That's design, it's supply, it's installation and commissioning, and it's also through the operating life. And all of those elements are required to make the innovation successful. One further example, a totally different scale. One of the big challenges with offshore wind is, you're operating in a potentially dangerous environment, often far offshore, often exposed to difficult conditions of wind and wave and weather. And so you really need to pay a lot of attention to keeping all the people safe. And typically one of the challenges is that when you do need to get a technician or anyone from onto a turbine, that's a fixed structure, and you're doing so typically from a moving vessel. And a totally different example of a key innovation is a new access system called Get Up Safe, and this works by lasers mounted on the wind turbine that are targeted at the deck of the vessel on which the person seeking to transfer is stood. And in that way, in a very clever piece of product development and engineering, a cable can be lowered automatically to that person, and as he or she is standing on the deck moving with the waves, the cable will similarly move and be still relative to the person. They can then safely clip on and be safely lifted up onto the turbine. It avoids any potential complications and de-skills what could be a quite tricky traditional process for transferring from a moving vessel onto a ladder on the turbine structure. And that also means that person is avoiding the sometimes tiring, sometimes time-consuming task of climbing up the ladder as well. That is an innovation that we've implemented on the Hornsea 2 offshore wind farm. That's currently in construction. It's enabled us to simplify and optimize the structure of the foundation. So we've been able to eliminate the whole structure for vessels to push onto the foundation and that ladder that previously people had to climb up. So that's a cost saving. Every cost saving contributes to reducing the cost of energy and thus addressing that energy trilemma that existed 10 years ago. These innovations, it's a range from design, from product, from manufacturing, from installation, and also through life. And I think the overarching lesson from innovation in onshore wind was that with that framework of a demanding target, which at the time looked so stretching, what we were able to do as an industry was mobilize all participants in that industry to play their part, to leave no stone unturned, to have that target of a lower cost of energy, and then invite and stretch for innovation in all areas. And those areas included everything from finance through to design of products, through to supply and building new higher capacity, higher efficiency manufacturing, to more efficient and timely installation, to quicker commissioning and thus quicker revenues, and also lower operating costs through life. Looking through that whole chain, no stone unturned, no participant in the supply chain or the funding parties not involved, everybody, if you like, working towards the same ultimate goal. And that really unlocked the amazing progress to go from what was typically £150 a megawatt hour for what was needed to bring an offshore wind project to an investment decision, to where we are today, where it's less than £40. And that journey's been done in less than 10 years. It's enabled us to move to a place where we can now add clean, indigenous electricity supply, connect it into our grid, and do so at a cost which is more than competitive with new fossil-fired power plants. So it's a fantastic place to be. You can see offshore wind farms of today, they are out of sight offshore. They are hundreds of turbines. Those turbines are a scale beyond any that you see these days onshore for wind farms. And there's a supply chain, an installation vessel chain, and an operating industry all set up to deal with that scale of product and that scale of operation that's required and demanded investment and innovation in all those parts of the supply chain. It's required funders to step up. And perhaps if I step back a bit, back to the start of that story 10 years ago, it's also required consistent supportive framework from regulators and government. And actually, to match that stretched target from 10 years ago, or almost 10 years ago, to match that stretched target with a supportive regime that enabled developers to bring forward their projects, to see a way through to the revenues that were needed to make investment decisions, to then build those offshore wind farms that have been the steps on this journey, and learn by doing it, and then feed that learning back through the funding parties who are able to take a new view of the risk and get comfortable without really high risk premiums, to feed it back to the manufacturing supply chain that were then able to invest to upscale and improve efficiency. And I think that also then goes on to the developers and sponsors themselves, who build the confidence to invest in new generations of turbines and transmission assets, and be confident that cycle of innovation is going to work without inducing unnecessary risk. So it's a multidisciplinary approach. It needs that overarching framework, and perhaps most importantly, it's a learning by doing exercise. I hope that's been interesting. I'm looking forward to the rest of the conference. I'll see you soon.
So hi and welcome. I'm Peter Couch, Chief Executive Officer of the Joint Radio Company. At JRC, we work closely with UK network operators, gas and electricity, both transmission and distribution, to address their operational telecoms requirements. I'm pleased to be hosting this panel session, which is focused on the net zero agenda and how we can learn from international development initiatives. It would be great to get a perspective from Europe and the USA on a range of innovation projects, in particular, Germany's lessons learned from the SINTEG innovation projects and plans for its energy transition, European net zero projects that are promoting the decarbonisation of the energy system, and the USA's net zero projects and focus for 2030 and 2050. From my perspective, it will be very interesting to understand how the initiatives described have been able to coexist with existing network infrastructure and be integrated into the energy market more generally. From a housekeeping perspective, we will take questions to all panelists via the chat, and speakers will respond as the session proceeds. Please feel free to ask questions or make observations as they relate to the individual presentations. To get things underway, I welcome Heiko Stobitz, Senior Manager, Smart Grids and Energy Storage at Germany Trade and Invest, who will be talking about Germany's lessons learned from the SINTEG innovation project and plans for its energy transition. And with that in mind, Heiko, I think it would be helpful if you were also able to explain how the SINTEG program relates to other programs in Germany. Thank you.
Yeah, thank you. Thank you very much for the introduction. So, dear ladies and gentlemen, what are the key lessons learned from the SINTEG program? So this is the topic for today, and SINTEG is the abbreviation of Showcases Intelligent Energy. And so before I start, what is the connection between Germany Trade Invest and the SINTEG program? So the SINTEG program is also funded or is funded from the Federal Ministry for Economic Affairs and Energy. So that's our shareholder. So, but more important, that is that we already worked 4 years together. So just from the beginning of this program, we worked together, and so we have a good insight in this program and to give you information about this program. And for us, it was very good because SINTEG shows an overview about the German market, about the development, about things learned in the electricity market. So it was very good because we are looking for innovative companies worldwide if they want to expand on the German market and to help them to start their business in Germany. And so why did we need SINTEG? So this is you could see the power structure of Germany in the year 2014 and in the year 2024, and that's we phase out nuclear power at the end of 2023, and you could see that in the year on the right hand side in the year 2024, so that we have more energy coming from the Nassam part, and you see the red hills, and you see also that we phase out nuclear power, that you see the green valleys, so that there is a need for electricity in these regions. We have a lot of industry in these regions, and so therefore on one hand there is the plan to build new power lines. So we want to build 3 DC power lines. There is a need for energy storage. And maybe you already heard that we also, there's a coal exit in the year 2038, and that we want to increase the share on renewables till 2050 to more than 80%. So, and therefore we really need to find solutions for the future. And therefore the SINTEG program was introduced to find these solutions, not only for the next 10 years. It was to find solution for 2040, 2050, when we have shares more than 80% on renewables, very fluctuating wind and PV, so that we find solutions in then. The program, it's the total funding was 500 million. There were more than 300 partners involved, like grid operators, industry, but also from all players in the energy field were involved. And the very important thing were, we called it regulatory sandboxes, so that to open if there were some restrictions, regulatory restrictions, to open them for the companies which were involved in this program. And here on the next slide, you could see that there were 5 regions. So 2 in the southern part called sea cells, and and there's the 2 in the southern part. They were focusing on integration on wind energy and solar energy, and the projects in the northern part, the focus was to integrate wind energy. And the important thing is the regions were very large. So we used to have another program before it called ENIC. So that was, I think, 10 years ago they started this program, and the regions were very small. But this is important in this program, that we really have large regions. For example, wind node in the northeastern part, there were 5 federal states involved, and to find solutions for the future energy market. And here, this is because SINTEG, the SINTEG program, it will end at the March next year. So this is the end of the program, and this is already the new program. It's called Regulatory Sandboxes for the Energy Transition, and there will be in focus on hydrogen. So there's altogether there are 20 projects, and 12 of them, the blue ones, they are focusing on integration on hydrogen and this sector. So these are my contact details. So if there's later on any questions, so you can also contact me directly, and hope to see you also in the discussion in the chat. So thank you very much for your attention. Thank you.
Thank you, Heiko, for that highly informative presentation. I now welcome Antina Sander, Deputy CEO of the Renewables Grid Initiative, and she will be talking about key European net zero projects that are promoting the decarbonisation of the energy system, in particular the Paris Agreement compatible scenarios for energy infrastructure, a project which was run in consortium with CAN and EEB. Welcome, Antina.
Thanks a lot. The title is a bit clumsy, but we come back to it. So by the end of the presentation, you hopefully remember it. Renewables Grid Initiative. I'll show you first what this is. Are we on the second slide? Ideally, hope so. You see a whole bunch of logos on the left-hand side. All the logos are European transmission system operators. On the right-hand side, it's all logos of European environmental NGOs. This group, smaller, but these 2 different parties started to collaborate in 2009, recognizing that, yes, really, for the energy transition, something needs to happen with the electricity grid, but oh dear, it's not so easy to modernize and especially expand the grid, taking into consideration that civil society tends to be against. So 4 parties said, let's try to look into this together. Let's see how we can get the power lines built that we need for the energy transition, but also respect nature protection principles and take good care of societal concerns. From the very beginning of this conversation, the NGOs told the TSOs, dear TSOs, in principle, we believe in the important role of power lines, but in practice, we think you should be planning for much more ambitious scenarios. Those of you who are into grid development know that usually the story goes as you have a narrative, a storyline that describes the future of the energy system as you imagine it will be in a qualitative way. This is converted into figures. The figures are being put into models, and in the end you say, now these are the bottlenecks, this is where we need to build power lines. The problem from the perspective of the NGOs is that they set the scenarios. They don't have enough renewables. They don't really show that the system is going to be fully coupled. What if it was smarter? What if decentralization played a much more important role, etc., etc. And these questions, civil society not only asked to the TSOs that are members of RGI, but also to the 2 ENTSOs. Beautiful acronym, stands for European Network of Transmission System Operators. There are 2 of them, one for electricity, another one for gas. Both of them are mandatory clubs that have been established by the European Commission also in 2009, and both of them, as one of their tasks, have to deliver every second year a so-called 10-year network development plan that looks from a pan-European perspective at grid infrastructure investment needs. And what civil society has been saying for years is, dear ENTSOs, your scenarios, the scenarios that by now they are developing them together, that you have are just not compliant with the Paris Agreement. And this is why we established this project with a crisp name, Paris Agreement Compatible Scenarios for Energy Infrastructure, where especially funds were given to the two biggest European NGO umbrella networks, the European Environmental Bureau and the Climate Action Network Europe. We also brought in the international network RAN 21. And we worked together, especially having an eye on our special stakeholders, the both ENSOs, with a set of specific tasks. One was to scrutinize the scenarios that they work with in depth for Paris compatibility, which actually included that the Climate Action Network Europe would start with explaining to the ENSOs what Paris compatibility meant in the first place, which is not a piece of information that comes naturally to TSO modelers. We would also provide feedback on what would be plausible and desirable futures from the perspective and level of knowledge from civil society that should be reflected by the TYNDP scenarios. And on top of this, these two networks developed their own scenario as a contribution to the discussion supported by civil society. This was also an exercise to learn how you can collaborate as a multi-stakeholder network on scenario development in general, and we try to raise a bit of global awareness on all of this, which is what we are doing here today. So one more slide on the PAC scenario. You see the title page of the publication on this. This was indeed a collective research exercise of more than 150 NGO members of these networks and additional experts trying to look into existing studies and models to see what are the available solutions that we could put into this. And they came up with a set of data, a scenario that is 65% reduction of greenhouse gas emissions by 2030 and by 2040 net zero greenhouse gas emissions and 100% renewables in all sectors across Europe. And this has, of course, been a very significant contribution to the general European debate on what energy future we should actually plan for. What are we at right now? We hear from the ENSOs, with whom we've been talking for 1.5 years, that they especially appreciated that this project gave them access to new experts and expertise beyond the usual suspects that they usually engage with. We have to admit that we would have desired in an ideal case to have the PAC scenario as one of the storyline scenarios for the next TYNDP round. We are not there yet. It's not surprising. This is also a political issue. And of course, it's also a matter of discussing how can you actually implement this and be sure that energy security is not an issue. So we have started the conversation with the TSO community about implementation. We are aware that for the future, we need to involve more stakeholders in this conversation. And we also believe that a lot of conversations with the policy world need to take place to make sure that we have suitable policy frameworks to implement such a scenario. And I leave it here, and same as just said, happy to answer your questions further in the discussion. Thanks a lot for your attention.
Thank you for that, Antina. That was very interesting, and good to see how there's alignment across the both the commercial sector and the NGO sector in the context of that study. I now have the pleasure of introducing Mark McGranagan, Vice President of Innovation and Electric Power Research at the Electric Power Research Institute, and Mark is going to give us an introduction to a selection of zero carbon projects from the USA. So over to you, Mark.
Thanks a lot for the opportunity. I really appreciate it. And I thought I would give a little bit of a perspective on where decarbonization, starts at the community level and builds up from there. We have many projects and initiatives around the U.S. that we call them net zero energy communities, and now the term is kind of switched to net zero emission communities, but still NZE. And I thought it would focus on kind of this community level mission to decarbonize and contribute to sustainability. So next slide, please. We have a number of these projects at EPRI that we help coordinate around the country. There's many more projects than this, but this is just a highlight of a few projects, and they have different objectives, as I'll get into in a moment, but they relate to a combination of economics and focus on being able to purchase renewable energy together, as well as have renewable and decarbonized resources locally in the community as well, and also to contribute to flexibility needs of the grid for overall renewable penetration. So these zero net energy communities have a number of different objectives as we look around the country. Next slide, please. And they do happen at the a lot of them are focused at this kind of new build level and communities, but there's also many projects that involve retrofit priorities in existing and lower income neighborhoods as well, to try to make sure that we that this ability to contribute to decarbonization touches all aspects of the population, and they all have the ability to contribute. So we're very excited about that. Next slide, please. And when we look at these zero net energy or smart communities, there's a number of aspects to these communities that are objectives that relate to the decarbonization aspects, and energy efficiency, local generation, almost always energy storage involved, because resiliency is part of their objectives as well. They contribute to electric transportation with electric vehicle charging, building design and decarbonization at the building level, and then overall engaging customers in the decarbonization process. So those are some of the goals that get set up for these advanced energy communities. Next slide. And when we look at the communities, we look at the individual drivers that are put in place, and I think the important thing, we can go through each one of these. The decarbonization is clearly one of those drivers, but resilience and reliability is a driver. Cost and being able to manage energy use in a way that benefits the community in terms of their overall energy costs, and that involves integrating multiple resources, as well as taking advantage of new technologies that are coming out and making that part of the overall design. So we have to take kind of all these different objectives and integrate them into community design and implementation, and that's what is a goal in a lot of these smart community projects. And it's exciting to see kind of the decarbonization driven from the community level. We're seeing this initiative happening within industrial and multinational companies in their purchasing plans, focused on renewables and decarbonization. And as it happens at the community level, the community can essentially have the scale to participate, like one of these larger customers. So it's a very exciting area, and I look forward to chatting about this concept of zero net energy communities, along with other approaches and goals for achieving overall decarbonization objectives. So, and then thanks a lot. I really appreciate it and look forward to the discussion.
Thank you for that, Mark, and thank you to all the speakers. I think it was an interesting a set of perspectives. In particular, we have the bottom-up point of view from Mark, where the market, where there's local communities developing an approach to energy or zero carbon future. It was interesting to see the collaboration between the NGOs and the TSOs in the European example, and also specifically in the German example, the role of the regulatory construct in facilitating a transition from nuclear and coal, delivering a plan to facilitate the renewable future. So I think that was an interesting acceptance or recognition that this is a multifaceted challenge, and you potentially need to come at it from a range of directions to actually move the situation forward. I pose a question to the panelists. Can you provide your perspective on what are the priorities to fully decarbonize the energy system from your perspective, both immediate in terms of between now and 2030 and then moving through to the 2050 time frame? If I can hand that over to Heiko first, I appreciate your perspective, please.
Thank you for this question. So there's a in my last slide, I also showed about the information about the new program about hydrogen. So there's a big discussion in Germany if we go to a pure electricity sector, so that also to replace for in the mobility sector or heat sector, so that we also in the industry that they use a lot of hydrogen, and that would be a need to replace that coming from green hydrogen, so that it's not coming from natural gas, so that we can use green hydrogen, for example. And so there's a discussion, and that's also what we plan with the National Hydrogen Strategy to go in this direction. The plan is to have up to 5 gigawatt on electrolyzers to be installed, but when we first focus on the electricity sector, so at the moment, the share on electricity in our grid is 50%. So when we started with the feed-in tariff in Germany, that was in the year 2000. So we had around 5% mainly hydropower. And now we have 50% already. So that was in the first half of this year. And so we really increased that. And I think that was very important to have this program, as I mentioned at the beginning, if we look in the direction, if we have 80% or more on renewables in our grid, so that we find solutions how to integrate the amount of electricity coming from fluctuating resources like wind and PV. And there will be an oversupply, so that's what we already had. We curtailed around 5 terawatt hours in the last years every year because there was an oversupply, and we had to curtail, for example, wind farms, and there's the need to find solution, and that might be also an opportunity for hydrogen to use them for this place.
Okay, thanks for that, Heiko. Antina, could you give us your perspective, please?
I have to start from the hydrogen, even though I didn't have it on my list. One thing is that I wish the notion would go away that hydrogen is a good alternative to electricity. It's needed for, of course, industry, heavy transports, things like this. We should get rid of the idea that hydrogen may be an easier solution than electrification because it's so much more inefficient. In the context of this, I think it's really important that political clarity is increased. For the short and medium term, what I hear from my network is the technical challenges can be resolved, but there is a need for real political guidance in which direction to go. And as I just said, I believe electrification, very high shares of variable renewables, also more decentralization are part of this. Why is this political guidance so important? Because many things, many relevant actors are not going to move unless we have the right policies. That refers to industry that has to make massive investments, and they need to be sure that they invest in the right place. We need to have the right policies, market rules, etc., to make sure that new actors, new kids on the block that play important roles in the energy system of the future actually have access to the market and can develop their business models. We also need policy guidance to see that people behave in the way they have to behave, the way they travel, the way they live, etc., to ripe, for example, the energy efficiency. How do you say this? Sorry, English is not my native language. To get to what we need to achieve there to make this possible. So we need to have the policy frameworks on the one side, and we need to work on policy implementation, because having policy is one thing, but implementing it is another thing. We want to have grid expansion, but it's damn difficult. And I want to mention one more other aspect. We need to understand the space needs of what we are planning for. And we need to reconcile these spatial needs with nature protection needs. Because for what we have to plan onshore and offshore, the space that we are going to need is massive. And we cannot throw the kit out of the bath. Do you say this in English as well? By thinking we can resolve one thing, but not thinking about the other aspect. And our ecosystems are super important. I leave it there.
Okay, thank you for that, Andina. And Mark, could you give us your perspective, please?
Yeah, and I'll give you a little bit of a U.S. perspective. At EPRI, we have a project that we call Project 2X and beyond. And the 2X refers to the fact that in the last 12 years, we've gone from about 6 gigatons of carbon per year to 5 gigatons here in 2019, 2020. And we think that to get in between now and 2030, it's very realistic to get to 4 gigatons, which is, doubling the reduction that we've achieved in the last 12 years, through kind of the technologies and approaches that are in place. Continued penetration of renewables, solar and wind are the most economic resources to put in place right now. Widespread electrification, especially transportation, continued improvements in efficiency, that these trends are in place. There's no need to change those to get this next gigaton out of the system. But beyond 2030, that's where we start getting to very high penetration levels of renewables and solutions that are where the answers are not as clearly defined. Hydrogen and low carbon resources like hydrogen are definitely part of the equation. The need for long-term storage becomes a very critical requirement at that stage. And so, and as we see with Hiko's presentation, we have to work on those solutions now if they're going to be the solutions that we need to implement in 2030 and beyond. And so we are starting a major initiative in that space at EPRI and coordinating with the rest of the world and how we will achieve that long-term storage. Also looking at things like modular nuclear and where what role technologies like that will play. On the policy side, obviously, things like carbon tax would be and other approaches to put some economic value on the decarbonization goals are really needed to continue to incentivize the market. But they really aren't needed to get to where we need to in terms of continued penetration of renewables and electrification, because those trends are clearly in place already. But the longer term approach needs policy measures as has been described.
Okay, thank you for that, Mark. I suppose one obvious question that springs to mind from what we've discussed today is, are there any obvious unintended consequences from what we're planning in relation to the general stability of the network and our ability to ensure that the lights stay on in terms of consumers' need and be able to support consumers' needs in an economically sustainable way? So the question is, are there any unintended consequences from the drive towards renewable and the significant shift and transition away from a very well established and secure and robust energy delivery mechanism?
I used to work 10 years for a utility company before, and so the question was quite often if we have large shares on renewables, if it will be really a problem for the grid operators to handle these. So at the beginning there was a big discussion in Germany, and many people said, okay, we will have blackouts and they will cause big problems. But so till now everything was to handle, but we also need to find solutions and to solve these problems. And I think that was very good on one hand, we introduced new markets so that you could, for example, you could we have this primary control, secondary, and tertiary control power market, and that also on the wholesale market that now in former times you can now 15 minutes before the electricity is needed. So there was the introduction of new markets in this field, and so till now the grid is very stable and we find solutions, but that's also that was the good thing about this SINTEG program to really look in the future and to find to solve these problems and to work together with all the partners involved. And so I think that yeah, I think at the beginning it was a big discussion, but from my perspective, the grid operators and the TSO companies, so I think they can really handle this.
Thanks for that, Heiko. Is there any other thoughts from Antina or Mark on that point?
I think I can underline that you phrased unintended consequence. I think from the transmission system operators, an unexpected realization was that they are able to handle a lot more than what for many years they said would be possible. So that's certainly on the positive side. What also comes to my mind in terms of unintended consequences is the thought that I think there are still many people out there that think there should be a silver bullet somewhere. In the beginning, the solution, the narrative, how to resolve climate change was, well, renewables. And no one thought about, not no one, but most actors didn't think about the consequences for the system. And then it became clear grids are part of the solution. And then you come up always with a new, yeah, this is painful. Can we do it in a different way? Can we build it underground? No, not necessarily always possible. Can we be more energy efficient? Yeah, but then we have to electrify many things. Perhaps if we do everything decentralized, we don't need these ugly power lines anymore. Oops, that doesn't work either for a variety of reasons. Now we have the hydrogen story. So for me, a bit an unintended consequence is to have to face the fact that there is no silver bullet, that this is a difficult transition and that we have to deal with it. But there's no way out. And I think we need to be honest to each other, and we need to, build up partnerships, collaborations, find alliances to work on the solutions together, because the clearer the picture you get on this is, the easier it will be to do something which is a very complex exercise.
Thank you for that, Antina. And Mark, do you have any thoughts?
Yeah, I'll second that. I think one thing that's very important is as we go down this path of electrifying more and more of our energy use, the importance of our electric supply becomes greater and greater. So, that emphasizes the need for resilience, which is already critical in our electric system and only becomes more critical. I know my friends in New York talk about electrifying the transportation system and the buses and electric vehicles. And then when there's a disaster and we lose electricity, we lose all our transportation, so that is something to consider. And I think, we just heard that the importance of the grid and the requirements for the grid as we decarbonize, and electrification is part of that. We really need to figure out how to develop, modernize the grid along with the resources that are going to help us achieve the decarbonization. That is, I think probably that's underemphasized still in terms of how important it is.
Thank you for that, Mark. That's I think the emphasis on electricity as we move forward is definitely points to the importance of the ability to ensure resilient supply of that very critical component of everyday life. I just thought it was probably worth reflecting on with net zero becoming an increasing priority for administrations across the planet. it has been great talking to you today to get a real perspective on the initiatives that are underway to deliver this zero carbon energy solution. And I mean, I think it's self-evident from the discussion that there are many aspects and there are many facets to this supply dynamic that need to be addressed as we move towards a zero carbon future. I just wanted to pick up on a final thought and to wrap up, and I welcome your perspectives on the one thing that you would identify as an important or critical change to enable zero carbon solutions to be more easily deployable in order for society to be able to truly benefit from the zero carbon future that we're targeting so significantly. The UK government has recently introduced its 10-point plan to net zero, and within that they've targeted a date of 2030 by which they will ban the supply of combustion engine vehicles in the market. So I think that there are probably sticks and there are probably carrots that need to be provided to the market in order to facilitate such a significant and profound transition. But it would be interesting to get your immediate thoughts on what would be the one big thing that you would target from your experience in your perspective.
Because the topic of it was lessons learned. So for maybe it's not the big thing, but it's a small but important step, which in Germany was the SINTEG program, which we did, and this was the first time that it was possible if you have an existing regulatory framework, and exactly for the program that it was able to change this one. So that because normally as an industry customer, if you have a stable consumption, so you get a better grid fee. But for the in this SINTEG program, it was possible. So because renewables are more flexible, and so it doesn't make really sense to give a better grid fee if your consumption is stable. And so they said, okay, if you want to be part of this program, so you do not have to pay more money because now you have not more than 8,000 full load hours, for example, or on a stable consumption, so that they offer the opportunity if you're in this program. So if your consumption is not so stable, if it's more flexible, then you still get the better grid fee than before. And I think that it's important, and that was one important lesson learned. And the other thing, in the old energy program, after the program it stopped, and there was it really stopped. There was so the people went away, and there was nothing ongoing. And the good thing about the SINTEG program is really even if it ends on March, the people in the program already started to create new programs, to work together, to find solutions, to find cooperations. So I think that's also really important. What we learned from this program. Not we have for years, and then it stopped, and everybody goes away. So they really still work together. They find new ways, and that it's an ongoing process. And I think that was very important also in this program, what we learned, how to use it in the future.
It's an interesting observation, the importance of collaboration and cooperation within in such a complex dynamic. It's fundamental to the whole thing being delivered in an accessible and meaningful way into the market. If I could hand over to you, Antina, I appreciate your thoughts on this question.
I don't believe in the silver bullet. The one big thing, if I have to name one, it's all the many different small things that you need to do to bring society along. We cannot do this without bringing society along. I really appreciated Mark's presentation on the zero carbon communities. In many circumstances, when you go local, people see that they have to bear a burden and they don't see any benefit for them out of it. And it's an impossibility to change something if people are against. So it's things like community wind parks, the opportunity to financially participate in developments like this. It's also community compensation where this is not possible, thinking about reduced electricity bills for low-income households, thinking about how do you create jobs in this new world for those who will not have jobs from the old world anymore. It's also about the nature protection. You can do beautiful things actually in grid corridors if you do proper vegetation management. There's many bits and pieces, and it's really about showing and also explaining to local people, look, this is not a disconnected, somewhere far away topic. There's something in it for you here directly, and then it's also easier to bring them along to move towards the big picture of the energy transition, which otherwise for many people is when it impacts them directly, it becomes a scare rather than an inspiration, and this we really need to deal with.
Thank you for that, Antina, and appreciate your thoughts. Just handing over to you, Mark, and you're able to provide us with your perspective on this question. We'd appreciate it.
Yeah, it's definitely a good one, and I'll agree that with the view that there is no one silver bullet, but I do think that there's a need for markets and platforms that really allow participation of all the stakeholders, customer, community, DSO, aggregators, flexibility providers in this energy equation, and that takes the market right down to the customer from a total energy perspective, not just an electricity perspective. And so that's what a lot of the research efforts are headed in that direction. But it's a worldwide issue what the markets look like when we take it all the way down to the community and the customer, but we still need to make the grid work as part of that equation. So, and there's still a lot of questions about that. So I'll say markets and platforms that include the value of decarbonization, whatever that is, carbon taxes or other value approaches, and integrated with the market approach.
Brilliant, Mark. Appreciate that. And I'd just like to call this panel session to a close and thank the panelists for your contributions today. It's been very interesting to understand the breadth and depth of perspectives and developments, both in the UK, in Europe, and in the US. And I think you brought those to life in terms of your content today. And very much appreciate your response to the questions that have been posed, and thank you for your contributions.
Thank you to our guests for that incredible insight into just what's required to deliver a net zero energy system. I'd like to say a sincere thank you too to our sponsors and to all of you for attending this morning's session. And now I'd like to invite you to do something different. I'd like to invite you to take a virtual stroll through the exhibition halls and innovation halls. You'll be able to browse the demonstrations, fill digital swag bags with videos and other content, and take advantage of conversations with technology innovators and project leaders during our live exhibition stands over the next coming hour. You'll also notice some pop-up messages at the bottom of the screen during these events. These will guide you to special events as they happen, so please do look out for them. I really hope you enjoy the rest of the day. I hope you make new connections and come away with a wealth of information to support you in our role to help transform the energy system. Have a good day.